Hello, I welcome all of you to my channel, Engineering and Info. If you are new to my channel, please subscribe it. Today we will discuss about normal distribution applications in the practical life, specifically in the engineering problems. So we will start. Question number one: a certain type of a battery lasts on average 3 years. Means a company may be, you can say, Devo. The Devo battery, it claims that our battery has an average life of 3 years with a standard deviation of 0.5 year. Means few of the battery may last for 3.5 years and may they work for 2.5 years. Assuming that the battery is normally distributed, find the probability that the given battery will work or will last less than 3 years. So first thing, we will write here what is our mean value and how we will represent our mean. So our mean is equal to 3 years. Our standard deviation is equal to 0.5. Important thing is what is our random variable. Okay, so what my random variable in this case is life of the battery. Okay, so what I say, x is equal to battery life or life of battery. We are interested in battery life. So now we have to calculate that what is the probability associated if our battery life is less than 2.3 years. Maybe there are batteries of which life is less than 2.3 years and we have to find that. So in most of the cases, please remember that such figure has not been given to you people. So you have to, if the figure is not given to you, what you have to make like this bell-shaped curve initially, and then you have to draw its central line, its mean value, write here 3, and then look at the value of the random variable, whether your value lies to the right or left of this random variable. So our random variable value 2.3 lies somewhere like this, at this point 2.3. Why I mentioned 2.3 so far away from 3? Because our standard deviation is 0.5 years. So it means that 2.5 slice something here, and I have written again 2.3 left to the at the left to the end of standard deviation, and we are interested in this area. Why I drawn this figure for you people? Because this figure will help you, number one, graphically understanding. The second one, if you are confused at which table should I have to use, a positive z distribution table or negative z distribution table, so this figure will tell you that you will have to use negative z distribution value because the mean value of the battery is less than our overall process mean, that is 3. So the z value, standardized normal distribution value associated with this random variable, will also be negative. So let's start this problem. First of all, you will have to write the formula of the z distribution. So z is equal to x minus mu divided by sigma. Put the value of x 2.3, mu 3, standard deviation, sigma 0.5 as the values has been put there. We got z is equal to 1 minus 1.4. As obvious, it will lies towards on the left hand side of the mean value. So now you will have to write that the probability that is associated with the random variable x and the value specifically when the x is less than 2.3, then you will interpret this x in terms of z, standardized normal distribution, and you will write this 2.3 into minus 1.4. You have converted it 2.3 to minus 1.4 using this formula. So what we will do now, we will go to standardized normal distribution table. In that table we will convert this z value into the area under the curve. So area under the curve, this will the area, and the area that table will give us, the area under the curve will be equal to our probability. So now I am going to the z distribution table that has been provided at the end of your book. So let's go there. I have opened this table A.3 areas under the normal curve. So My z value calculated was minus 1.4. I came downward in the column, so until I will check minus 1.4 and minus 144 there, and associate with it the first column value 0.00. So the probability associated with this minus 1.4 is 0.0808. Let me go to the presentation again. So you can check here that the probability associated with the battery whose life is less than 2.3 is 0.08. Now we will study about interpretation. How we will interpret it. Interpret. So we will say that there is only 8.08% chance or probability that the battery of a specific company having mean value 3 and standard deviation is equal to 0.5 will last for 2.3 years. I hope you like this problem. Now we will go towards the next problem. Second problem, an electrical firm manufactures light bulbs that have a life before burnout that is normally distributed with mean equal to 800 hours and standard deviation of 40 hours. Let's suppose we say that the company, a famous manufacturing company, Philips. The manager of the Philips claims that the bulb they are manufacturing has a life of 800 hours on average. So mu is equal to 800 hours and standard deviation of 40 hours means that the bulb they are manufacturing maybe have a life of 840 or on the maximum side and 760 on the least least side minimum age or minimum life of the bulb. Then the manager says that what is the probability that the bulb they are manufacturing it burns between 778 and 834 hours. Means he, in simple word, the manager says that calculate the probability that the bulb they are manufacturing have a life of at least 778 hours and a maximum of 834 hours. So you will have to check here what is the random variable we have. So random variable is equal to life of bulb. Here the life of bulb is in hours. So we have the two values of the random variable 778 and 834. Now in this question you will have to again draw a diagram for your graphical diagram. Then it's draw its mean central line. So central line 800 life at one side, 834 be on its, you can say, right side, and 778 will be on its left side. Now you will have to, the value 718 is less than the mean value 800 and 834 is above the mean value, so it will be on the right hand side and above mean value. Why we are using 718 on the left hand side, 834 on the right hand side? Because in the earlier videos I have told you that our lower tail is on the left hand side and our upper tail of the normal distribution is on the right hand side. So that's why we keep our the value that are lesser than mean value on the left hand side and the value that are greater than the mean value on the right hand side. So now we will write the z formula because we have to convert over random variables into the standardized z value. Formula of the z is x minus mu. Please memorize this formula divided by sigma. So in the first case 778 will be our random variable value and mean value is 800 given in the question. Sigma standard deviation is 40 years. Then for the second case 834 will be my value of the random variable, 800 mean, 40 is the standard deviation. By using the calculator you can easily calculate the value of z1 and the value of z2. Now you can say that 770, the value of z1 is equal to minus 0.55. This is the value associated with 778 and z2 is equal to 0.85 and this is the value that is associated with the 834. So for we have converted the values of random variable into the standardized z distribution. The next step will be we will go towards the table and we will check the values of the area under the curve, or you can say in other words, you will check the values of the probability that lies the probability of this blue shaded region. So again a question arises based upon we have solved the similar question in the previous videos, that a table will give us the value from this extreme left hand side, technically you can say from the lower tail. So we got our value of 0 minus 0.55 from this extreme lower end, means from this value. You will say this area will be equal to A1, and then 0.85, this value we got from the table. The probability associated with 0.85, the probability will be equal to from the extreme left hand side till this line, the random variable value 8.34 or z is equal to 0.85. So we will get this probability equal to A2. But we are interested in this blue shaded region, and this probability, we can't get the probability of this blue shaded region from the table directly. So what we will do, we will subtract over, we will say that this blue shaded region is equal to A3. So A, you can say A3. So A3 will be equal to A2 minus A1, because A1 is the region from lower tail till this point, and A1 is the region from this lower tail this till this point. So when we will subtract this more area, that is A2, from this region A1, from this whitish region, we will automatically get this whole blue region probability. Same is the case that has been done here, that we are going to find the probability of our random variable x, and the probability we are interested in between 778 and 834. We have converted these random variables into associated z values, and then we say that we are in the probability of z less than 0.85, that is greater than, you can say, the region we are interested in, and probability of z less than 0.55, it starts from the extreme lower tail till our random variable value 778 or z is equal to minus 0.55. We have found the probabilities of these two regions using z distribution tables, and now we got a final probability equal to 0.511. So if we want to interpret it, how we will interpret? We say that there is 51.11% probability that the bulbs that has been manufactured by the Philips International with a mean life of 800 hours with the standard deviation of 40 hours will last between 778 hours and 830. You are quite familiar with the ball bearings because they have most important applications in almost all of the mechanical equipments. So let's solve an example related to the ball bearings. In an industrial process, the diameter of a ball bearing is most important measurement. The buyer sets a specification for the diameter is 3 plus minus 0.01 centimeter. So this information will be used in order to set the lower and upper specification limits. Let me write lower specification limit. Specification limits are those that has been provided by the buyer to the manufacturer, that the buyer says that I will either accept the ball bearing that lies between 3 minus 0.01 centimeters, or I will accept with the upper, you can say USL, upper specification limit will be equal to 3.0 plus 0.01. So the buyer will say that my lower specification is 2.99 and my upper specification limit is 3.01. In other words, the buyer said that if the ball bearing is between 2.99 to 3.01, I will accept it. And if the ball is smaller than 2.99 or it is greater than 3.01, then it will be rejected from my side. He will not accept it. So the manufacturer says that I have a process or that the process that has been used in my industry, it have a mean of 3.0 centimeter, and the standard deviation of this process is 0.005. Now the manufacturer is interested at how many manufactured ball bearing will be scrapped, because in this case upper and lower specification limits has been provided by the supplier. These questions are basically for the normal probability distribution, but in the course of quality control you will also face such type of problems. So first of all, we will over random variable is now a random RV over random variable is now in this case is the diameter of the balls. And how you identify that whether this is a whether this is a continuous distribution or discrete? Over random variable has a value in after the point, so it's not a discrete value, it's a continuous value, so distribution will also be a continuous one. So now our aim is to convert these two random variable values of the random variables into the z distribution using this formula z is equal to x minus mu divided by sigma. Put these two values, the value of mean and standard deviation, in this formula. So we will get over z1 value here to the value associated with 2.9, and this is our random variable value, and the z value associated with this random variable value is minus 2.0. And when we put 3.01 in the formula, we will get c2 is equal to plus 2. So plus 2 is the value of the random variable 3.09 in the standardized z distribution format. Now we will go to the table and we will check the probability that has been associated with minus 2.0 and plus 2.0. Please remember, the probability, the area under the curve that we took from the normal distribution is equal to probability of this region. So when we calculate the probability for minus 2.0 from the table, the probability value will be from this lower tail till this point we will get the probability. But when we see the probability, when we look at the probability for plus 2.0, remember that the value of the probability we get from the table will be from this point to this point. Okay, so please don't make any mistake. We are interested in this region, but the table will give us the value from this point to this point. So if you listen to my previous lectures, I have told you that the area under the curve is equal to 1. So area under the curve, it is equal to 1. So what you will do, you will subtract, you are interested in this region, so what you will do, you will subtract, let's suppose it is equal to a2, you will say, and this is a3, so you will say my a3 will be equal to this whole region, the whole region will be equal to 1 minus the probability that we get from the table, it is equal to a2. So let's move towards the table in order to find the probability for the area A3 and the area A1. So let's go to your book. So the first value we are interested in is minus 2.0. So minus 2.0, the value is 0.0228. Let me highlight it for you people. And our second value was 2. So look at this table A.3 and the value 2 is 0.9772, but remember you will have to subtract this value from 1. So let's go to the presentation again. So 0.9772 is the value we got for our area A2. I will write here 1 minus 0.9772 and we get A3 is equal to 0.0228. This is the probability for A3, you can say, for this region 0.0228. And again the value that we calculate for minus 2 from the table, was quite obvious that it was 0.228. So the whole probability for that random variable will lie between 2.99 and 3.01. Convert these random variables into z values and then look these z values in the table. You got 0.0228 plus 0.0228. Calculate them, take summation of them, and you will get the result. So it will be equal to 0.0456. Let's go to the next numeric. So we will start with the next problem. This problem is slightly different from the previous ones. So let's start. Gauges are used to reject all components for which a certain dimension of a product is not within the specifications. The specification of the product is 1.50 plus minus d. D, you can say it's the deviation, okay? And this deviation, some value in plus and minus means in upper specification limit or lower specification limit is acceptable. Beyond that, the part will be rejected. So it is known that this measurement is normally distributed with mean is equal to 1.5 and standard deviation is 0.2. Determine the value D such that the specifications cover 95% of the measurements. Now I will explain this whole statement by using the figure that what has been stated in the question. So from the last line, it says that cover 95% of the measurements. It means that the process will produce 95% good parts and 5% bad parts. So we will say the 5% bad parts, some of the parts will be on the above specification limit towards the above tail and half of on the lower tail. So the parts will be rejected on the upper tail. So 2.5%. And 2.5% of the parts will be rejected on the lower tail. Now this is basically the percentage of the components that will be rejected. So in this case we have the probability P, we haven't any value Z, and we haven't any value of our random variable X. I hope now you got what the problem says. So what we will do, we will go directly to the tables. Instead of using the formula of Z is equal to X minus mu divided by standard deviation, we will check what is the value of the Z associated with this, the probability 2.5. If I remove the sign, the percentage sign, we will get 0.025 and 0.025 on both sides, on lower tail as well as on the upper tail. Now when I go to the table, it's quite obvious that this value on the lower tail, I will get this value, I will get the Z value of 0.025 directly from the table, because this value will be easy for me to calculate from the table because this value has been provided in the table. But the value that will start from this point till this end point, it is not possible for me to get this value directly from the table. So what I will do, I know that the area under the curve is equal to 1, this whole area, and this 0.025 or 2.5%, if I remove this one, or if I remove 0.025 from the one, I will get 0.975. So I will use two probabilities, 0.025 for this lower tail and 0.975 for the upper tail. So let's go to the tables in order to find the Z values. So my first value is 0.025. This one value, I'm going to highlight it, and the value of Z is associated with this is minus 1.96 on this vertical axis, 0.06 on this horizontal axis. We got minus 1.96, and for the second value 0.975, I will use this table. So in this table the Z value is minus 0.975. So yeah, this is 0.975 highlighted value, plus 1.96 is on the vertical scale, 0.06 is on the horizontal scale. So we got 1.96 on the upper tail and we got minus 1.96 on the lower tail. So I hope now it's clear to you why it is written that our z value lies between 1.96 positive minus 1.96, and associated with these two z areas our probability is 0.95 or 95%. So this value cover 95%. I have explained all of this concept, that how this 95% comes, and along with this probability how you will calculate the z values. Once you got clear upon this concept, now it's quite easy for you to use the formula. You will say that z is equal to x minus mu divided by sigma. In this case you have the value of the z 1.96. You don't know the value of x clearly, but you know that the value of the x is, for the positive value you can say that it will be equal to 1.5 plus d minus mu is given here 1.5 divided by sigma is equal to 0.2. In the next step, multiply 1.96, cross multiply this 0.2 here, multiply by 0.2 is equal to 1.5 plus d minus 1.5. Okay, this 1.5 will be cancelled from each other and you will get d is equal to 1.96 multiplied by 0.2, and this will be equal to, your d will be equal to 0.392. Okay, so this is the value of the d you have calculated. Now you can say my upper specification limit will be equal to 1.5 plus 0.392. This will be equal to, and my lower specification limit is equal to 1.5 minus 0.392. So this was the whole problem. Please calculate by yourself these two values. This is just addition and the subtraction. I hope. So the question is, a certain machine makes electrical resistors having a mean resistance of 40 ohms and standard deviation of 2 ohms. Assuming that the resistance follows a normal distribution and can be measured to any degree of accuracy, what percentage? So this is of our interest. This word means we have to now interpret also this question by the end of when we solve that, we have to give the percentage and we will interpret that percentage of resistors that will have a resistance exceeding, again this one is also in our interest, exceeding 43 ohms. So I will explain this question related to the quality control. Let's suppose the engineer or manufacturer say that we will reject the resistors whose resistance is greater than or exceeding 43 ohms. So you will have to calculate the probability of the resistors whom resistance is greater than 43 ohm. So the mean is 40. Obviously our random variable of interest has a value of 43 that is greater than 40. So that value lies in the graphical on the right hand side. We will have to check greater or exceeding the random variable value. Okay, so we will make this area shaded. However, if we change the statement of this question, if the manufacturer says that calculate the probability of the resistors that have a resistance less than 43 ohms, then our area of interest was this whole whitish region. So the word exceeding or word lower than, this is most important in the coming chapters of your problem, as it is related to the quality control again. So we will have to calculate the probability of the resistors that will be rejected. So again simply apply the formula of the z, x minus mu divided by sigma. This will be equal to, x is equal to value of the random variable 43, mean given 40, resistance standard deviation is 2, we got z is equal to 1.5. Now the question is, we have z value, either we have to check less than 1.5 or more than 1.5, because we got z is equal to 1.5 associated with 43. So You can explain, you can answer this question by looking at the statement exceeding 1.3. It means the value that is greater than 1.5. But the table will give you the value from this lower tail till this line or till 1.5. So what you will do, you will calculate, you know that the whole probability area under the curve is equal to 1, and when you subtract this 1 from this region or this probability, you will automatically get the probability of this shaded region. So we have calculated the probability of 1.5, means the area under the curve for z value 1.5 is the probability, and we have checked the table so many times. So I will left this time table looking at you, and when you check the z value 1.5, you will got 0.9332. 1 is the area under the whole curve. Okay, so you got 0.0668. How you will interpret? You will say that there is 6.68 percentage of the resistors are present or manufactured by our process whom resistance is greater than 43 ohms. But this is the end of this question. The question that is related to the result of the students. Let's suppose the average grade for your exam is 74 and the standard deviation is 7. Your teacher says that if 12% of the class is given A, means 12% of the students in a class have A grade and the grades follow normal distribution, what is the lowest possible A and highest possible B? So as you know that the junction of A and B is same, means you can say that 3.33 is the junction value, above which it will be a grade and below which we got B. So 3.33 is a junction, you can say. Also you can say at that junction point above which, this is the junction point, above which there are 12% of the students who got A grade. So we will have to check that value of the junction. In simple words, that value of the junction, in case of you can random variable, you can say we have to calculate the marks at which the students got A grade, the least marks at which the student got A grade, and there are 12% of the students who have already obtained that grade. Also we have to check the area z value that is associated with this x. So we will have to move backward. Percentage has been given to us. Percentage is 12%. Remove the sign of percentage. You got p is equal to 0.12. When you have the probability, always go back, always follow the back process. Calculate the value of the z using the probability. Then calculate the value of the random variable using the given value of the z. So we have provided with the value of probability. I'm going to the table to check the value of the z that is associated with this 0.12. The question arises in you, maybe the question arises in your mind that why we are taking the upper tail of this normal probability distribution in this question, because you always know that least marks are always on the left hand side, and as the marks or as the value of the random variable increases, we move towards the right hand side. Our random variable has maximum values on its upper tail, so that's why we took A grades on this side. Okay, this is for your concept that why we took 12% on the upper tail or why we took the value 12% on the right hand side. One thing more, that table will give us the value from this point to this point, but we haven't calculated so far the value of the z, or we haven't the value of this random variable x for this point. So what we will do, we say that the 12% of the area lies to the left from this line. So how much area will lies, or what will the probability of this white region? The whole probability of this region is 1, and you can say that 1 minus 0.12, this region will give us the probability of 0.88 for this whitish region. Now for 0.88, I will check the value of z, and this z value will lie here. You can see that the value of the z, it lies 1.1 there. You can see it's 1 0.8810 and 0.8790. So we took 1.1 from this vertical axis, and this is the value that has been qualified, this value that has been qualified to be picked, and the value on the x-axis 0.08. So the z value become 1.1 plus 0.08, that is equal to 1.18. Now we'll go to the presentation. We have calculated the z value, and the z value is equal to 1.18. Now, as we are interested in the marks that will distinguish between A and B grades, so the marks will be of random variable. Now we have calculated the value of the z. We will transform this z value into the random variable value x. So by using the formula that z is equal to x minus mu divided by standard deviation, we have the value of the z from the table, that is 1.18 is equal to x is unknown to us. The mean marks are 74. Standard deviation is given 7. 7 will be cross multiplied with this. So we took 7 multiplied by 1.18 will be equal to x minus 74. Let me calculate it using the calculator. So 7 multiplied by 1.18, it will be equal to 8.26. So we will get 8.26 is equal to x minus 74. Take 74 on the left hand side, so it will be 8.26 plus 74, and it is equal to x, and x will be equal to, randomly equal to, you can say 82.26. So this is the junction point, okay, above which 12% of the students got A grade, and this is the junction point of grade A and grade B. So that's the end of all the questions that are related to the practical application of normal distribution. Hopefully you have a lot of questions. You can ask these questions in the comment section. If you're new to my channel, please subscribe it. My mobile number, WhatsApp number and email has been provided. If you have any question, you can contact me anytime. Best of luck for your future. Bye bye.